So in this session, we will be discussing about WKB approximations connection formula. So what is connection formula? Okay, let's discuss connection formula. Okay. So far, whatever we have done in quantum mechanics, whether it is a bound problem or a tunneling problem, whatever problems we have done so far, we have assumed that the potential is somewhat vertical and we have smooth boundaries and so on. Okay. But let's assume that at some point, let us say, if this is the energy and this is the x-axis, so these points, at these 2 points, what will happen? E become equal to V. The energy of the particle become equal to the potential at that point. So that is the point where the non-classical region, that is, this is the non-classical region. Okay, so this is the non-classical region. Here also this is non-classical region and this is the classical region. So this non-classical region and classical region join together at this intersection points where E is equal to V. These are the important point. Now let's consider this very simple problem. So suppose you have a problem like this. So I'm now putting this to be the origin. Okay, I'm shifting the origin. Now our potential somehow goes like this. Oh, sorry. Now the potential somehow goes like this. Okay, let us assume that this is how the point. So okay, so this is the V of x. Okay, now this is the point of energy. This is our E. Okay, now here this is non-classical region and here it is classical region. Okay, so this is a classical region and that's a non-classical region. Now by WKB approximation, on the left hand side of the origin, that means x less than 0, we can write the wave function psi of x is equal to 1 by root of px, some constant b e raised to I integral x to 0, all right, p of x dx plus c e raised to minus I, well, there should be some I by h cross, yeah, I h cross integral x to 0 p of x dx. Clear? Now this is the wave function on the classical region because it's an oscillatory function there, and in the classical region the wave function is oscillatory. Now for x greater than 0, the wave function is exponential function. Clear? And it's an increasing exponential, you can see from here. Okay, now that is 1 by root of p of x. Since p of x is complex, we take the mod of it, d e raised to minus 1 by h cross integral 0 to x mod p of x dx. Now there will be, obviously you will be thinking of some e raised to 1 by h cross, some positive exponential may be there, but there is a problem because this x goes to infinity. From here, this is a positive sense, so here the x goes to infinity. So at infinity, what will happen? If you have a positive exponential term, so that at infinity this explodes and becomes infinity and everything will be collapsed. So to make this wave function 0 at infinity, you should have only e raised to minus something. Okay, so that's why you will not have a positive exponential term on the right hand side. Now there is a problem. So these are the two separate, one is oscillatory and the other is exponential. You have two wave functions, but these two wave functions meet at the point of origin, or x is equal to 0, that means E is equal to V point. Now what will happen at that point? At that point there is a trouble, because you know that the P of x is somewhat proportional to root of E minus V term. Now if E is equal to V, the P of x becomes 0, and in both these cases you have P of x in the denominator, so the entire function explodes 1 by 0, it becomes infinity. So the wave functions will not yield a definite value at the point of intersection, or at this x is equal to 0 point, or at E is equal to V point. So that's a problem here. So how can we manage it? So in that case we will be patching a wave function. A patching wave function can be used at this point, which we will be considering here. So here, for example, let's consider a very small portion. Okay, so here we may assume that this wave function or the change in this potential. Okay, so maybe consider like this. All right. So now I can assume that the V of x in the approximity of the origin can be said as E plus, that means that energy plus some V dash of 0 x. You know, this is a straight line. See, this small portion is a straight line. So I am introducing the equation of this straight line. Y is equal to mx plus c. So c, what is c? C is the this height. All right, obviously the intersectional height. Now v dash is the slope. Actually y is equal to mx plus c. So here m is the slope of this curve. Now v dash is the slope. What is v dash? V dash is dv by dx at 0 actually. So that's why I am calling it as v dash of 0 into x. So this straight line, this small patch which we consider here, can be considered as a straight line, and we can put that equation here in this form. Clear? Okay. Now the Schrodinger equation at that point can be rewritten as minus h cross square by 2m dou square psi p. So this patch, wave function at this patch, that's what I call psi p. Okay, so minus h cross square by 2m dou square psi p by dou x square plus, okay, so now what is the potential? It is simply E plus V dash x psi p, V dash of 0 actually, okay, sorry, is equal to E psi p. Alright, now I'm rearranging it so that I will be getting dou square psi p by dou x square is equal to what? Take it on the right hand side, so that is 2m by h cross square v of 0 dash, alright, so psi p into x, right? This is correct. Now I put I introduced a term alpha, something like 2m by h cross square v dash of 0. I call, the 1/3 power of which I call as alpha. Right. So this is what, actually this is alpha cube. So now dou square psi p by dou x square is equal to alpha cube x psi p. Good. Sorry. Now put z is equal to alpha x. Okay. So now if I put z is equal to alpha x, now what? Dou psi p by dou x is equal to dou psi p by dou z into dou z by dou x by chain rule. Alright, good. Now what is dou z by dou x? Dou z is equal to alpha dou x. Dou z by dou x is alpha. So that is alpha dou psi p by dou z. Now dou square psi p by dou x square is equal to alpha dou psi p by dou z, dou square psi p by dou z square dou z by dou x. That's alpha square dou square psi p by dou z square. Clear? So instead of this, I can put this. These are same. So now I can write alpha square dou square psi p by dou z square is equal to what? Alpha cube x psi p. Oh, x. What is x? X is z by alpha. Z by alpha psi p. So alpha square. So that is simply dou square psi p by dou z square is equal to z psi p. Good. Now this equation is called Airy's equation. Airy's equation. This equation is known as Airy's equation, and its solutions are called Airy functions. Airy functions. Clear? So these are called Airy functions. So actually the Airy equation is a second order differential equations, and there are two linearly independent Airy functions solutions because it's a second order differential equation. Two linearly independent Airy functions will be there. One we will be calling as ai of z, and the other we will be calling as bi of z. Okay, these are the two Airy functions, and every solution is a linear combination of these two. Okay, so for z very much greater than 0, the ai of z, I can approximate that into 1 by 2 root pi z raised to 1 by 4 e raised to minus 2 by 3 z raised to 2 by 3. 3 by 2. 3 by 2. And bi of z is equal to 1 by root pi z raised to 1 by 4 e raised to 2 by 3 z 3 by 2. And if z much less than 0, in those cases, ai of z is equal to 1 by root pi minus z all raised to 1 by 4 sine 2 by 3 minus z all raised to 3 by 2 plus pi by 4. And bi of z is approximated to 1 by root pi minus z all raised to 1 by 4 cos 2 by 3 minus z all raised to 3 by 2 plus pi by 4. Okay, so these are the approximate solutions of approximate Airy functions of the Airy equations. So linear combination of these are the solutions. Now the psi p. Okay, psi p is a linear combination of what? These two Airy functions. So I can write the solution at this patch region. ഇതിന് ചുറ്റുമുള്ള let me show you what I mean by that. So this region, actually I'll be considering this region. It's a patch region. Okay, so this region I'll be considering it to be something like this function. The wave function would be a linear combination of ai of alpha x, because alpha x is we consider that as set b bi of alpha x. Clear? So now this is the approximate wave function in the neighborhood of what you call origin. Okay. Okay. Now now what is p of x? Okay. നമ്മുടെ പ്രശ്നമൊക്കെ ആരംഭിച്ചത് ഈ പി ഓഫ് എക്സിൽ നിന്നാണ്. പി ഓഫ് എക്സ് സീറോ ആയതുകൊണ്ടാണ് പ്രശ്നം. ബട്ട് നൗ വി റീപ്ലേസ്ഡ് ദ വി ഇൻ ദി ബാക്ക് സെക്ഷൻ by something, so that now the p of x can be written as root of 2m into e minus, so what is e minus e plus v dash x, sorry v dash x, right? Now what is that? Root of 2m minus v dash, sorry 2m of 2m of e minus e cancels, so v dash minus v dash x, that is root of 2m v dash of 0 into root of minus x എന്ന് എനിക്ക് എഴുതാം. But what is our alpha? Let's consider what is our alpha. We have discussed the alpha somewhere here. Yeah, 2m by h cross, that is 2m by h cross, right? 2m by h cross, v dash of 0, v dash of 0 all raised to 1 by 3, right? That is the alpha, right? Yeah. Now see this. So alpha cube is 2m by h cross v dash of 0. So there is h square, I think it should be h square, yeah. So 2m v dash of 0, or I can write 2m v dash of 0 is equal to alpha cube h cross square, correct? Or root of this is what we want here, yeah? So root of 2m v dash of 0 is equal to alpha raised to 3 by 2 h cross. So put that back into this equation. So p of x is now equal to h cross alpha raised to 3 by 2 root of minus x. Good. So we got the p of x. So so now let's check our picture. So here in this region, that is a non-classical region, the wave function is somewhat exponential, right? So in that case, integral 0 to x p of x dx I can write as h cross alpha raised to 3 by 2 integral 0 to x, what is that? Okay, we will be taking the mod actually, so root of x dx. We are not bothered about the minus sign here. Why? Because we take the mod here, see. So now what is that? X raised to 3 by 2, x raised to half, so that is 3 by 2, right? Sorry, 1 by, okay. So that is 2 by 3 h cross alpha raised to 3 by 2 x raised to 3 by 2, right? This is it, correct? Okay, correct. Now that is it. Now what was the wave function there? What was the wave function there in this non-classical region on the right hand side? The wave function was, we have written it I think somewhere here. No, I think connection formula, yeah, this is the wave function on the right hand side, all right? So we got this, okay. So now the wave function can be written as d divided by, okay, now root of h cross alpha raised to 3 by 4 x raised to 1 by 4 e raised to minus 2 by 3 alpha x all raised to 3 by 2. That's very good. Good. Is it clear? No. This is not clear for you. Okay, let me show you what actually we have done. See, on the right hand side, that means x greater than 0. On the right hand side, this is our wave function. This is our wave function. Now in this wave function, p of x എന്നുള്ളതിന് പകരം integral p of x 0 to infinity, 0 to x p of x dx എന്നുള്ളതിന് പകരം ഞാൻ എന്ത് കൊടുക്കുന്നു? ഇതിന് പകരം നമ്മൾ എന്ത് കൊടുക്കുന്നു? 2 by 3 അല്ലേ, h cross alpha raised to x, what was that? Alpha x all raised to 3 by 2 എന്നുള്ളത് കൊടുക്കും. Now, okay, so that is it. E raised to that, e raised to this. And p of x, what is p of x? H alpha, root of p of x. Upper root of h cross alpha raised to 3 by 4, root of x, root of x inde adinte root, so that is 1 by 2, so that is x raised to 1 by 4. അത് രണ്ടും കൊടുക്കുമ്പോഴാണ് നമുക്ക് എന്ത് കിട്ടുന്നത്? So far we got this. Is it clear? Good. Now this e wave function ആണ് റൈറ്റ് ഹാൻഡ് സൈഡിലുള്ളത്. അപ്പം നമ്മുടെ എയറി ഫംഗ്ഷൻ അനുസരിച്ചിട്ട് പാച്ചിൻ്റെ വേവ് ഫംഗ്ഷൻ നമുക്ക് എന്താ കിട്ടിയ? psi p is equal to ai of alpha x plus bi of alpha x എന്ന് കിട്ടിയിട്ടുണ്ട്. ഇത് രണ്ടും എന്തായി മാറണം? ഇത് രണ്ടും സം പോയിന്റിൽ വെച്ചിട്ട് മെർജ് ചെയ്യല്ലേ, ഈക്വൽ ആവുകയല്ലേ ചെയ്യുന്നത്. റൈറ്റ് ഹാൻഡ് സൈഡിൽ ഇതാണ് നമ്മുടെ പാച്ചിൻ്റെത് വേവ് ഫംഗ്ഷൻ, അതിന് അപ്പുറത്ത് ഇതാണ്. അപ്പോൾ ഇത് രണ്ടും കൂടി എക്സ് ഇസ് ഈക്വൽ ടു 0 എന്ന് പറയുന്ന പോയിന്റിൽ അല്ലെങ്കിൽ സംവേർ ദർ ഇറ്റ് ഷുഡ് മെർജ് ഇൻ ടു. Okay, now we can consider, we have already shown that the Airy function for the exponential case, Airy function, okay, so sorry, here, yeah, so this is the Airy function. So Airy function is for z greater than 0, this is the form of it. So we put back that into this equation. So I can write this is equal to a by 2 root pi alpha x all raised to 1 by 4 e raised to minus 2 by 3 alpha x all raised to 3 by 2 plus b by root pi alpha x all raised to 1 by 4 e raised to 2 by 3 alpha x all raised to 3 by 2. അപ്പോൾ ഇത് രണ്ടും ഈ ഇക്വേഷനും ലെറ്റ് സേ ദിസ് ഈസ് 2 അല്ല വേണ്ട 3 ആൻഡ് ദിസ് ഈസ് 2. These two equations should become equal. So in that case, let's compare this. You have a minus exponential, you have a plus exponential, but here you have in equation 2 you don't have any plus exponential. So this b becomes 0, no b. Now you compare this. So the exponential terms are same. All right, the exponential terms are same. So what remains is a by 2 root pi alpha x all raised to 1 by 4 is equal to d divided by root h cross alpha raised to 3 by 4 x raised to 1 by 4. Okay, x raised to 1 by 4. Now from that I can write a, the unknown constant in the Airy function. This becomes a becomes what? D into 2 root pi, okay, alpha raised to 1 by 4 x raised to 1 by 4 divided by root of h cross alpha raised to 3 by 4 x raised to 1 by 4. 3 by 4 1 by 4 cancel ആയിപ്പോയി. So what remains is 1 by 2 alpha raised to 1 by 2. So ബാക്കിയെല്ലാം റൂട്ടിനകത്താണ്. So now this is root of 2 inside the root, so I can write 4 pi alpha h cross d. So that is the a. That is the a. Okay. So this a into ai of alpha x. Now that is the solution 1. Okay, on the right hand side. Now let us look at the left hand side. So what is the left hand side? If I take the left hand side, then the equation is integral x to 0 p of x dx. Okay. Now if I do that, we'll get the same answer, no problem. But here you will be having 2 by 3 നമുക്ക് നേരത്തെ കിട്ടിയല്ലേ h cross, but here you are not taking the not taking the modulus of it, because you have the p of itself. So h cross minus alpha x all raised to 3 by 2, you have to consider that. Now so you got the integral 0 to p of x. Now what was the psi of x, which is oscillatory inside the lower limit? So what was that? The equation we have is, what was that? See here, what was that? For psi less than for x less than, so this is the equation for Mendel. So x less than 0, for x less than 0, psi of x we have got it as let me check, as 1 by root of p of x b e raised to I by h cross integral x to 0 p of x dx plus c e raised to minus I by h cross integral x to 0 p of x dx. Clear? Now what is root px? What is root px? Root px, we have already got it somewhat, like we have already found out it in the root px is 1 by root h cross, നമ്മൾ നേരത്തെ കണ്ടുപിടിച്ചതന്നെ, alpha raised to 3 by 4 x raised to minus x raised to 1 by 4. Okay. Ini b e raised to I by h cross. Integral ഇത് കണ്ടുപിടിച്ചു, നമ്മൾ ഈ ഇൻ്റഗ്രൽ കണ്ടുപിടിച്ചു ഇവിടെ. അപ്പോൾ h cross ഉണ്ട്, ക്യാൻസൽ ആയിക്കോളും. സോ ദാറ്റ് ഇസ് 2 by 3 അല്ലേ, മൈനസ് ആൽഫ എക്സ് ഓൾ റേസ് ടു 3 by 2 പ്ലസ് സി e raised to minus I 2 by 3 minus alpha x raised to 3 by 2. Good. Correct? Now this is the exponential function. Now this exponential is a linear combination. This is the wave function on the left hand side, psi. Now that should be equal to psi p at those region. ഇതിൻ്റെ റൈറ്റ് ഹാൻഡ് സൈഡിലേക്കുള്ള ലെഫ്റ്റ് ഹാൻഡ് സൈഡിലേക്കുള്ള റീജിയനിൽ എന്തായിരിക്കും നോക്കൂ. ഇതിൻ്റെ ലെഫ്റ്റ് ഹാൻഡ് സൈഡിലുള്ള റീജിയനിൽ ക്ലാസിക്കൽ റീജിയനാണ്. ഇവിടെ ഓസിലേറ്ററി ഫംഗ്ഷൻ, അതാണ് ഇപ്പോൾ നമ്മൾ കണ്ടുപിടിച്ച സൈ. പക്ഷേ ഇവിടെ ഈ പോയിന്റ്, ഇതിൻ്റെ നിയർ ബൈ പോയിന്റുകളിൽ, ഈ ചോപ്പിട്ട പോയിന്റുകളിൽ അവിടെ എന്തായിരിക്കും സൈ പി എന്ന് പറയുന്ന സാധനമാണ്. ബട്ട് ഓൾസോ ഹിയർ സെഡ് ഈസ് ലെസ് ദാൻ, ഒരു ആൽഫ എക്സ് ഇസ് ലെസ് ദാൻ 0 അല്ലേ, ഇതിൻ്റെ തൊട്ടിപ്പുറത്തെ പോയിൻ്റാണ്, മുൻപേ ഉള്ള പോയിന്റുകളാണ്. സോ അവിടെ സൈ പി എന്തായിരിക്കും? സൈ പി ഈസ് യൂഷ്വലി നമ്മൾ എ ഐ ഓഫ് ആൽഫ എക്സ് പ്ലസ് ബി ഐ ഓഫ് ആൽഫ എക്സ് എന്നൊക്കെ പറഞ്ഞിട്ട് നമ്മൾ ഉണ്ടാക്കി. നമ്മളിനി അതിൻ്റെ വാല്യൂ നമുക്ക് കണ്ടുപിടിക്കാമല്ലോ. കാരണം വെൻ സെഡ് ഇസ് much less than 0. In that case, we already know, we have written somewhere on the top, exponential anengil ai of z is equal to, or alpha x is equal to, okay, let's say alpha x is equal to 1 by root pi minus alpha x all raised to 1 by 4 sine 2 by 3 minus alpha x all raised to 3 by 2 plus pi by 4, and bi of alpha x is equal to 1 by root pi minus alpha x all raised to 1 by 4 cos 2 by 3 minus alpha x all raised to 3 by 2 plus pi by 4 എന്ന് കിട്ടിയിട്ടുണ്ട്. ഓക്കെ, സോ ഇതിൻ്റെ രണ്ടിൻ്റെയും ലീനിയർ കോമ്പിനേഷനാണ് നമുക്ക്. സോ എ ഇൻറ്റു ദിസ് പ്ലസ് ബി ഇൻറ്റു ദിസ് ഈസ് ദ സൈ പി. ഇനി ഈ സൈ പിയും ഈ സൈയും എന്തായിരിക്കണം? ഷുഡ് ബി equated. Okay, so now you compare these two things. Okay, you compare these two things. Okay, so this is minus, so minus plus, okay, no problem. So now you have a cos function here. So when you compare this and equate the coefficients, what will happen? Let me try to do this. Okay, what will happen? Let me check it. 1 minute. Okay, that's so I can write now the psi p, the patch sign, is equal to a by root pi minus alpha x all raised to 1 by 4 sine 2 by 3 minus alpha x all raised to 3 by 2 plus pi by 4 plus b by root pi minus alpha x raised to 1 by 4 cos 2 by 3 minus alpha x all raised to 3 by 2 plus pi by 4. Okay, now what? Okay, let me check. B and C, you have to find out in terms of B and C. Let me try to do this. Okay, so psi. Okay, so നമ്മൾ ഇവിടെ ചെറിയൊരു പ്രശ്നത്തിലാണ് അല്ലേ. ഓക്കെ, നോ പ്രോബ്ലം. ലെറ്റ്സ് റൈറ്റ്. ഈ സൈനും കോസും ഉള്ളതുകൊണ്ടാണ് നമുക്കൊരു, ഇവിടെ ആണെങ്കിൽ എന്താണ്, എക്സ്പോണൻഷ്യലാണ് നമ്മുടെ ഇതിനകത്ത്. അപ്പോൾ നമുക്ക് സൈനിനെയും കോസിനും എന്ത് ചെയ്യാൻ പറ്റും? നേരെ എക്സ്പോണൻഷ്യലിൻ്റെ ഫോമിലേക്ക് ചെറുതായിട്ട് മാറ്റാൻ പറ്റുമോ എന്നുള്ളത് നോക്കാം. ഓക്കെ, okay, sorry. Now there is a trouble. Actually, I have is equal to this. Okay, sorry. Okay, we already got b is equal to 0. This I forgot. We already got b is equal to 0. For the patching function, patch wave function, b is equal to 0. So we don't have to consider the b is equal to 0 here. because b is equal to, we have to consider the b is equal to 0 here. So this entire term goes cancelled because we already calculated the b to be 0. So don't worry, now this is very simple, it's going to be very simple, that's what I was thinking. Okay, so good. Now this is a by root pi minus alpha x all raised to 1 by 4. Okay, sine ആവുമ്പോൾ എന്തായിരുന്നു 1 by 2i ഓർമ്മയുണ്ടല്ലോ, e raised to I, okay, this entire term I pi by 4 into e raised to I 2 by 3 minus alpha x all raised to 3 by 2 minus e raised to I pi by 4 e raised to minus I pi by 4 minus I 2 by 3, okay, 2 by 3 minus alpha x all raised to 3 by 2. E raised to I theta minus e raised to minus I theta divided by 2i, that is sin theta. Okay, so that is sin theta, sin of this entire term. Okay, now that is it. Now you compare this with this. Okay, now you compare this with this. This random compare idonka. So you will be getting, anyway, just compare it, writing it. So you will be getting a by 2i root pi e raised to I pi by 4 is equal to b by root of h cross alpha, and minus a by 2i root pi e raised to minus I pi by 4 is equal to c by root of h cross alpha. So now on rearranging this, we will be getting b is equal to okay, and you have already found out a in terms of d. Okay, so put that back also here. So we will be getting b is equal to minus I e raised to I pi by 4 d, and c is equal to I e raised to minus I pi by 4 d. So these are the connection formulas we will be using. These are the so-called connection formula. So രണ്ട് സൈഡിലെയുമുള്ള വേവ് ഫങ്ഷൻസിനെ കണക്റ്റ് ചെയ്യുന്ന കണക്ഷൻ ഫോർമുല എന്ന് പറയുന്നത് ഇതാണ്. സോ നമ്മളൊരു നോർമലൈസേഷൻ കോൺസ്റ്റൻറ്റ് ഡിൻ്റെ ടേമിൽ എഴുതുകയാണ് എങ്കിൽ ഒരു വേവ് ഫങ്ഷനെ സൈ ഓഫ് എക്സ് എന്ന് പറയുന്ന വേവ് ഫങ്ഷനെ നൗ ഐ ക്യാൻ റൈറ്റ് ഇറ്റ് ആസ് 2d by root of px sin 1 by h cross integral x2 x2 some point p of x dx plus 1 pi by 4 for x less than x2. ഒറിജിനൽ പോയിന്റിന് പകരം ഒരു ആർബിട്രറി പോയിന്റ് x2 ആയിട്ട് ഞാൻ എടുക്കുന്നു. or psi of x is equal to d by root of mod p of x exponential minus 1 by h cross x2 to x mod p of x dx for x greater than x2. So this is it, wave functions. We will be getting wave functions. Good. So we will be getting this. These are the connection formulas. We will be getting the connection formula, and thereafter we will be getting the right wave functions. So it's a little bit lengthy derivation, but still you can do it provided you know the Airy functions, how it behaves when z is much less than 0, and how the Airy functions behaves when z is much greater than 0. ആ സാധനങ്ങൾ നമ്മൾ ഓർമ്മയിൽ ഉണ്ടാകുന്നത് നന്നായിരിക്കും. Okay, now let's go for the example. A potential well with one vertical wall. So that is a problem. So that means what is a one vertical wall? So here it is. you have an infinite wall on left side, and your energy, the particle energy, is this. Okay, now this is the wave function, it changes like this. Okay, so v of x changes like this. So this is E. So the crossing over point is, let us say, x2, an arbitrary point. Good. Good. So what will happen at x is equal to 0? X is equal to 0. Psi of 0 is equal to 0, because it cannot go outside, because this is an infinite wall. Now, in that case, from the previous equations which we have already derived, these are the two equations. So in that case, we can say integral. So this is on the x2 in the left side. So left side x less than x2. So that let's consider this. So you have to consider this equation. This equation. So this is equation. So ഇത് എന്താണ്? 0 ആണ്. ഇത് 0 ആവുക എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഈ ആർഗ്യുമെൻ്റ് എന്താവണം? n pi ആവണം. അതല്ലേ എൻ്റെ സാധനം? So now I can write 1 by h cross. See, മനസ്സിലാവുന്നുണ്ടോ? സൈൻ ഓഫ് സംതിങ് 0 ആവുമെന്ന് പറഞ്ഞാൽ ഈ സ്ക്വയർ ബ്രാക്കറ്റിലുള്ള 1 by h cross ഇൻ്റഗ്രൽ 0 x to 0 അല്ല 0 to x2 p of x plus pi by 4 എന്ന് പറയുന്നത് എന്താവണം? സൈൻ ഓഫ് ദാറ്റ് 0 ആവണം. സൈൻ ഓഫ് ദാറ്റ് 0 ആവുമെന്ന് പറഞ്ഞാൽ 1 by h cross ഇൻ്റഗ്രൽ 0 to x2 p of x dx plus pi by 4, that is the argument of sine of this, is equal to 0 എന്ന് പറഞ്ഞാൽ this should be equal to n pi. Good. This should be equal to n pi. That means integral 0 to x2 p of x dx is equal to n minus 1 by 4 h cross pi. Rearranging it. That is it. That's we got. Now, ഒരു ഹാഫ് ഹാർമോണിക് ഓസിലേറ്റർ ഉണ്ടെന്ന് വിചാരിക്കുക. ഒരു സൈഡിലേക്ക് മാത്രമുള്ള ഹാർമോണിക് ഓസിലേറ്റർ. So that means v of x is equal to half m omega square x square for x greater than 0, and it is equal to 0 for x less than 0, or otherwise. Now in this case, we can write p of x is equal to root of 2m into e minus half m omega square x square, right? Half m omega square x square. That is e minus v, 2m into e minus v. Okay, good. M into minus v. So I'm just taking the 2m inside, so that means it's 2me minus 2 and 2 get cancelled, m square omega square x square. Now I am taking m square omega square outside, that is m omega, 2me divided by m square omega square minus x square. So when x is equal to this point, p of x becomes 0. So ആ പോയിന്റ് പി ഓഫ് എക്സ് 0 ആവുന്ന പോയിന്റ് ആണല്ലോ നമ്മുടെ ട്രാൻസിഷൻ പോയിന്റ് എന്ന് പറയുന്നത്. എന്ന് പറഞ്ഞാൽ ഈ ചിത്രം നോക്കുകയാണെങ്കിൽ ഇവിടെ ഇതാണല്ലോ ട്രാൻസിഷൻ പോയിന്റ്, ഇ ഈസ് ഈക്വൽ ടു വി ആവുന്ന പോയിന്റ്. അപ്പോൾ ഇത് രണ്ടും സെയിം ആവുക എന്നുള്ളതല്ലേ, അതിനെയാണ് ഞാൻ x2 എന്ന് വിളിച്ചത്. സോ x2 ഇസ് വാട്ട്? x2 ഇസ് ഈക്വൽ ടു ആക്ച്വലി സിംപ്ലി വാട്ട്, 2 m ക്യാൻസൽ ആയി പോയിട്ടുണ്ട്, 2e by m omega square, or 1 by omega root of e by 2e by em. So that is the x2. our x2. Clear? So that is the x2. So now what is it? 0 to x2 p of x dx നമുക്ക് എന്ത് എഴുതാൻ പറ്റും? m omega p is equal to m omega integral 0 to x2 root of x2 square minus x square dx. So x2 square minus x square dx, x2 square minus x square dx എന്ന് നമുക്ക് എഴുതാൻ പറ്റും. ക്ലിയർ അല്ലേ? പി ഓഫ് എക്സ് നോക്കൂ. പി ഓഫ് എക്സ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഇതാണ്. പി ഓഫ് എക്സ് എന്ന് പറഞ്ഞാൽ ഇതാണ്. ഇതിനെ ഞാൻ x2 സ്ക്വയർ എന്ന് വിളിച്ചു. ഇതാണല്ലോ പി ഓഫ് എക്സ്. ഞാൻ അതിനെ പുറത്തെടുത്തു, എം ഒമേഗനെ പുറത്തെടുത്തു. ദാറ്റ്സ് ഓൾ. സോ ദാറ്റ്സ് ഇറ്റ്. Now you have to integrate this. So let's put x is equal to x2 cos theta. So dx is equal to what? Minus x2 sin theta d theta, and the limits changes to 0 to pi by 2. Good. X 0 ആവുമ്പോൾ 0, so it should be cos 0 1. So x 0 ആവുമ്പോൾ it should be 0. So then x2 ആകണമെങ്കിൽ cos so pi by 2 ആവും ഇവിടെ അല്ലേ. x 0 ആകുമ്പോൾ x2 ൻ്റെ വാല്യൂ തീറ്റയുടെ വാല്യൂ എന്തായിരിക്കണം? പൈ ബൈ 2 ആയിരിക്കണം. നല്ലത് 0 ആവുള്ളൂ. ശരി. പിന്നെ x2 ആവണമെങ്കിൽ ഇതിൻ്റെ വാല്യൂ കോസിൻ്റെ വാല്യൂ 0 ആയിരിക്കും. കോസ് 0 1. സോ x2 ആവും. അപ്പം പൈ ബൈ 2 ടു 0 ആവും ഇൻ്റഗ്രൽ. പൈ ബൈ 2 ടു 0 ആവും. പക്ഷേ 1 മൈനസ് ഉള്ളതുകൊണ്ട് 0 ടു പൈ ബൈ 2 ആയിട്ട് ഇൻ്റഗ്രലിനെ മാറ്റി എഴുതാൻ പറ്റും. സോ നൗ ഇഫ് ഐ റൈറ്റ് ഇറ്റ് m omega and you have this x square, എക്സിന് പകരം x2 സ്ക്വയർ ആവും. അപ്പോൾ ഒരു റൂട്ട് എക്സ് സ്ക്വയറിനെ പുറത്തെടുത്ത് കഴിഞ്ഞാൽ x2 സ്ക്വയറിനെ പുറത്തെടുത്ത് കഴിഞ്ഞാൽ x2 ഉണ്ടാവും. പിന്നെ ഡി എക്സിന് ഒരു x2 ഉണ്ടാവും. സോ ദാറ്റ് ഈസ് x2 സ്ക്വയർ ഇൻറ്റഗ്രൽ 0 ടു പൈ ബൈ 2 സൈൻ സ്ക്വയർ തീറ്റ ഡി തീറ്റ. ആൻഡ് ഇഫ് യു ഡു ദാറ്റ് യു വിൽ ബി ഗെറ്റിംഗ് x സ്ക്വയർ x2 സ്ക്വയർ m ഒമേഗ. സൈൻ സ്ക്വയറിൻ്റെ ഹാഫ് നമുക്കറിയാലോ. സോ ദാറ്റ് ഈസ് half theta 0 to pi by 2. So that is m omega square x2 square pi by 4. So m omega square x2 square pi by 4. So that is the integral. But okay, 2e by m omega square is equal to x2 square. 2e by m omega square is equal to x2. So 2e by m omega square. So what is that? So 2e by m omega square is equal to x2. 2e by m omega square is equal to x2 square. So if I put that here, m omega square into 2e by m omega square into pi by 4. What is that? M omega square. Some mistake I made. How is the m omega square level? M omega, sorry. So this is m omega only, sorry. So omega will be there. So that becomes pi e by 2 omega, correct? So pi e by omega. So integral 0 to x2 p P of x dx is equal to pi e by 2 omega. Correct? But we already got 0 to x2 P of x, the condition, other condition which previously we have derived, see, which previously we have derived gives you condition. Integral 0 to x2 P of x dx is equal to n minus 1 by 4 h cross omega, x cross pi. So P of x dx is equal to n minus 1 by 4 pi h cross. So equating these two, because on the right hand side, left hand side is same. So pi e by 2 omega is equal to n minus 1 by 4 h cross pi. So E is equal to 2 into n minus 1 by 4 h cross omega. That means 2n minus 1 by 2 h cross omega. So E is equal to 2n minus half h cross omega. Okay, so that is a beautiful result. So this is the exact allowed energy for a half oscillator. Okay, so that means this is if I put 2 minus half h cross omega, then you will have 2, that is 3 by 2 h cross omega, 7 by 2 h cross omega, and so on and so on. So okay, so 3 by 2, 7 by 2, and all. Good. So that is a very beautiful result of the half harmonic oscillator. Clear? Right? 2 minus half, 3 by 2. 4 minus half, that is 7 by 2. 11 by 2 and so on. So actually ഒരു ഹാർമോണിക് ഓസിലേറ്ററിൻ്റെ എനർജീസ് എന്തായിരിക്കും? ഇതിൻ്റെ ഒക്കെ h cross omega, half h cross omega, 3 by 2 h cross omega, then 5 by 2 h cross omega തുടങ്ങിയിട്ടുള്ള സാധനങ്ങളായിരിക്കും. 7 by 2 h cross omega. അതിനകത്ത് ഈ ഹാഫ്, അതുപോലെ തന്നെ അടുത്ത 5 അങ്ങനെയുള്ള സാധനങ്ങളൊക്കെ അങ്ങ് പോയി. അത് അപ്പുറത്തെ സൈഡിൽ, ഒരു സൈഡിൽ, ഇത് ഒരു സൈഡിലുള്ള എനർജി. So half harmonic oscillator energy നമുക്കിവിടെ കിട്ടുകയാണ്. So this is a beautiful problem. So this is the potential well with one vertical wall problem. So let's finish it. Thank you.